In section 5.6, we mainly discussed two theorems, and the first of which is called the angle bisector theorem. Angle bisector theorem. In our book, this is theorem 5.3, I believe. And that is when I have an angle and I have a bisector. So that means if I label this properly, I have points on all sides here, A, B, C, and D. So if BD bisects angle ABC, we have to label it using 3 letters. That way, if we use angle B, it could be referring to this angle, or the whole thing. Right? So, if BD is an angle bisector, then I know that means then I know angle ABD is congruent to angle DBC. Those angles are going to be congruent. And this theorem says that if those angles are congruent and BD is a bisector, then the shortest distance, so the distance between D and A and the distance between D and C, when they intersect and are perpendicular, so the shortest distance between a point and a line is that perpendicular line. It creates a perpendicular line. So it says that those sides that create those triangles are congruent. That is what the theorem ends with. So those two sides, AD is congruent to DC. So if I have a bisector, I have those two angles are congruent, and I have a point D here on my bisector, I can then draw the shortest distance, a perpendicular line, to either side, that side and this side, and those lines that I draw are going to be congruent. The second theorem that we use has a perpendicular bisector. So keep in mind, a bisector cuts it in half. So I know that if this is A, this is M for midpoint, this B can be at the end, B, and I have a point C. So if CM is a perpendicular bisector, of AB, well, I know that AM is going to be congruent to MB since it is a bisector. And this theorem says that if I have a point on that bisector, so we're referring to point C here, if I connect that to the endpoint A and to the other endpoint A, those are going to be congruent as well. Keep in mind that has to be a perpendicular bisector. Alright, so this theorem overall concludes with AC is congruent to MB. So when we're looking at, this is theorem 5.4, we're going to be looking for these congruent symbols and these right angles. I'm going to be looking for those congruent angles and the right angles as well, in the couple of example problems I will cover. Okay, so let's go ahead and try one of the checkpoints. So for the first checkpoint, I am going to use my knowledge from theorem 5.3. So I'm looking, do I have an angle bisector? Okay, well, the picture actually gives me those congruent angles there. So yes, I have an angle bisector, EH, which let me draw my H a little bit closer. EH is the angle bisector, and I have a point on that bisector, and it is drawn the distance, so that means I'm going to have a perpendicular right angle right there. So that means that these sides are congruent. Since those sides are congruent, this is me using the knowledge from that theorem, I can go ahead and set them equal. So x plus 3 is equal to 2x plus 1. In this situation, I need to solve for x in order to actually figure out what I need. So I'm going to subtract x from both sides. I get 3 equals x plus 1, and then I subtract 1 from both sides and get x equals 2. Well, I have x equals 2, and that's very good, but I need to figure out what fh equals, and fh is x plus 3. So that means that if I plug in 2 plus 3 is 5. fh is 5. Similarly, with the second checkpoint, it asks me for what mk equals. So mk is x plus 15, so I need to figure out what x equals before I can figure it out. I have jm is an angle bisector. So I have this angle in here is congruent to this angle. It's an angle bisector, and I have a point on that bisector. And when I'm taking my distance to JK and taking my distance to JL, and it's perpendicular, I know that those lines are going to be congruent, so I can set them equal. So all I'm really doing on these problems is setting stuff equal. If I subtract x for both sides, I get 3x equals 15. Divide by 3 on both sides, and I get x equals 5. Well, still not finished. That is very good, but I need to figure out what mk equals, and mk is x plus 15, so 5 plus 15. When I plug x back in, I get mk is 20. And on the last problem, I'm going to be using, it looks like I have a bisector here because 8 and 8, so it perfectly cuts this line in half, cuts EG in half, and it is a perpendicular bisector. So if I'm using theorem 5.4, and I flash back to it, then I know this side is congruent to this side when I draw a line from that point on the bisector to the endpoints. I know those lines are congruent. So that means that I can actually set those equal. So 2x plus 5 is equal to x plus 10. If I subtract x from both sides, I get x plus 5 equals 10. And I subtract 5, I get x equals 5. Am I finished? No. Problem asks for what GF equals, so I need to go ahead and plug that back in. 5 plus 10? 15 is your final answer.